methods. Now let's go to the second solution method. This is called the simplex method. And here again, we are going to look at the standard maximization problem. As we have repeatedly said, these problems, maximization problems and minimization problems, are convertible. And again, you already, I hope, understood why we are putting this rule that all the variables are going to be non-negative to confine it only one quadrant of the Cartesian plane. And all constraints have the form that the inequalities are less than or equal to 0 form. Again, the objective is not to talk about the infinitely large regions, but to talk about the limited regions. And we can talk about only the limited regions by making the constraints by less than or equal to 4. So this type of problems or other types of problems also can be converted into this type of problems. The second approach to solving this type of problems is the simplex method. So in the remaining time, we are going to look at this simplex method. It is a method for solving linear programs by hand. To solve a linear programming model using the simplex method, the following steps are necessary. Standard form. Let us repeat. What do we understand by the standard form? It's going to be a maximization problem. The variables are going to be larger than or equal to 0, and the constraints are going to be less than the boundary value. And we are going to introduce some variables here because we want to make the inequalities equality. To make the inequalities equality, we need to introduce some new variables, and these new variables are called slack variables. Then we are going to create a tableau or table. Then we are going to choose some variables which are called pivot variables. It's going to be clear soon when we make the example what we mean by pivot variables. We are going to select a pivot variable. Using this pivot variable, we are going to create a new tableau, and in each case, we will check for optimality. Checking for optimality in this case is looking at the last row or the lowest row of the table or the tableau. In the tableau, if the last row is all positive, that means that now I have found the optimal solution. Then I am going to identify the optimal values. So these are going to be the steps of simplex method. Now, we routinely apply steps and rules. This was a method developed during the Second World War. And they, of course, wanted to have an algorithmic method to solve some of the problems. Like, of course, the problems, they had something like, how can we maximize the area which we can bomb by using our airplanes and this type of problems? Or how can we bomb the maximum number of targets by using the minimum time and minimum fuel? These type of problems were all the type of problems which could be solved by the simplex method. And they developed some rules. And now we are going to see what these rules are and try to understand these rules by proceeding with a simple example. Okay, now there's a table. It may not be so obvious what these mean. They are going to be cleared though as we start to apply them in the example. But again, let's quickly go through the table to see what type of steps standard maximization problem involves. First, we will convert the system of inequalities to equations. So from inequalities, we will go to equalities. and we will introduce some select variables to do this. So we will also introduce another one to make the objective function equal to 0. So at least we can see that we are going to introduce 3 stack variables here. If I've got 2 constraints in 2 unknowns, I put 2 select variables. And also we put another select variables to make the objective function equal to 0 here. So that means normally we may need 3 stack select variables or more. And then we will create a tableau. Then we are going to identify a pivot variable. To identify a pivot value, we will first select a pivot column. This will be the column with the most negative number. And of course, we check all the time if all the numbers on the bottom are positive or non-negative. If all the numbers on the bottom row of the tableau are non-negative, then we are done. We found the optimal solution. Then we select the pivot row. We will see how we select these. And at the intersection of the pivot column and pivot row lies the pivot value. And then we perform some operations to make the pivot equal to 1 and the remaining elements in the pivot column 0. So if I can manage to do this, this is going to be called an active variable, and it's going to be one of the optimal values. If I cannot find this for a variable, then the variable is going to be called inactive, and its value is going to be taken as 0 in the optimization solution. And we will repeat this process until all the variables on the values on the bottom row are non-negative. And once I make pilot value 1 and the remaining values 0, then by using the rightmost entry of the row, I can figure out what the optimal value is. Now, this may be all too confusing now, but I just wanted to give you a preview of what the steps are going to involve. Of course, it doesn't make much sense from this table at the moment, but it is all going to be clear when we start to go through these steps one by one in solving the example problems. But this table is here, and whenever you are going to solve a problem by using the simplex method, you will come and look at this table. Active values, some literature is also calling them basic variables, are the variables which correspond to columns that contain only one and non-zero entries. Inactive or non-basic variables correspond to columns that don't contain any only one and non-zero entry. Okay, this doesn't make sense much at the moment, but it's going to make sense soon. This table I went through because from time to time we will come back and check what we must do from this table. Okay, it is helpful to understand these steps and rules with a simple example. Now we will go through each step in this table with the following example. Maximize this under these constraints. At the moment, this is a standard maximization problem because it is a maximization problem and all variables are positive and all constraints are less than or equal to 0 form. So how many select variables over here? First of all, we put the first equation into a form which is equal to 0 type. So if I put 0 to the left-hand side or equal to the right-hand side, and we are going to have this p as a variable now, as a select variable. So it's going to be one of my variables. So I'm going to make this equal to 0 also by adding 2 variables. something like S and T, or I can put any letter as select variables. So I will have three select variables, two variables X and Y, and three select variables. So I will have a tableau of three select variables plus two variables, five variables altogether. Now, from the table, I put the corresponding rules. First, say convert the system of inequalities to equations using select variables. So two select variables, we will convert this system of inequalities into equations using two select variables. Set the objective function equal to 0. We will set this equal to 0 by taking p to the right hand or left hand side and making the other side 0. And create a simple tableau and label the active or basic variables. Okay, so 2x plus y plus s, my first select variable, is equal to 5. Now it becomes, by adding this select variable to the first one, a equality. And x plus 2y plus t is equal to 4. So this is my second select variable. And minus 2x minus 5y plus p is equal to 0. So this p here becomes my third select variable. Okay. So these are my equations now. So I put them all into a tableau. Now, these are my equations, which will go into the tableau. So this is my tableau. X, Y, which are the first two variables. And then the select variables S, T, P. And in each row, I've got three rows now. I put the coefficients. So 2, 1, 1, 0, 0, and 5. In the second row, 1, 2, 0, 1, 0, 4. In the third row, minus 2, minus 5, 0, 0, 1, and 0. So far we have applied the first three rules of the table, which the steps and rules, which had altogether 9 items. The first three, now we have applied here. And we formed this tableau. And remember, how were we checking the optimization? We were looking at the bottom row. If at the bottom row, all the entries were positive or non-negative, then this would be corresponding to the optimal solution. At the moment, we see that there are two entries with negative values, so we are not at the optimized solution yet. We are going to make some manipulations in this tableau until everything at the bottom row become non-negative. Okay, so our aim now is to make some operations. So to try to make this bottom row all non-negative. Now, what were we doing for this? Let's remember, or let's just call in these items of the steps at the beginning. Now, we will look at the items 4, 5, and 6 now. It for the first says, select the pivot column. This is the column with the most negative number on the left side of the bottom. The left side of the bottom means is that if you look at this line here, the left side is here. So what is the most negative column? It is this. So this is going to be my pivot column. And then we will select the pivot row. And let's first select this pivot column. Then we will see how we select the pivot row. And then the pivot row, sixth item says, the pivot row and pivot column is going to be intersecting. And this is going to be the pivot entry, pivot number, and this number also must be positive. It must be positive. It can't be 0, it can't be negative. So first, if rule 4 or the step 4 says, choose the column with the most negative value at the bottom row, which is this column. So this is going to be my pivot column. Okay, so this is my pivot column. This is easy. Now the next is from this, I will go to this. It is, I am looking at the pivot column and looking at the entries of the rows. Here 1. So I am dividing this value of 5 with 1 here, finding 5. And this value here for dividing what by 2, finding 2. And now this time I'm looking at the smallest positive ratio. So I'm now applying rule 5 here. Select the pivot row. How do I select the pivot row? Divide each entry in the constant column, which is this, by the corresponding positive entry in the pivot column, which is this. So 5 divided by 1 gives 5. 4 divided by 2, which is 2. And the smallest positive ratio indicates the pivot row. So this smallest positive ratio is 2. So this is going to be my pivot row. So this is rule 5. Okay, so I am going to look at the intersection point of this. It is this 2. So this is going to be my pivot. 2 is going to be my pivot. So, but it must satisfy some rules. What is it? It cannot be 0, it cannot be negative. Fortunately, in this case, it is neither 0 nor negative. So I can select this 2 as my pivot value. What happens if it was 0 or negative? So we are going to look at the end to this case where it does not satisfy the positivity condition. But fortunately, in this example, the condition in 6 is satisfied. So this I can choose as my pivot value. So I have got 2 more steps, 7 and 9. Now I'm going to apply. So I've determined the pivot value. Now let us look at the other rules, what the other rules were saying in the table. We are going to perform row operations to make the pivot equal to 1, which is simply dividing by 2. If I divide all the rows by 2, it makes pivot equal to 1. This is simple. And the remaining elements in the pivot column equal to 0. So I'm going to make this 1 and this 0. Because the active value, which I called, or the basic value, appears only once all other elements are 0 in this column. So I try to make the other 0 here. Okay. So first I divided the pivot row by the pivot value. So to make this pivot value 1, then I'm going to try to make this 0. Okay, so I want to make this 0 and also this 0. In other words, I am trying to carry out this step 7. Perform row operations to make the pivot equal to 1. We had made it. And the remaining elements in the pivot column equal to 0. So these remaining ones, which are shown by green brackets, I'm going to try to make them 0. I do this by subtracting from the first row the second row. If I subtract from the first row the second row, of course, this is going to be 0. And I do this by adding to the third row 5 times the second row. Then it makes this also 0. Okay. So when I carry out these operations, my new tableau becomes this. Now I check also. Now when I am obtaining this new tableau, what happened to the bottom row? In the bottom row, all entries became now here, of course, look at this part, all entries became non-negative. Therefore, I have found the optimal solution. If I have found the optimal solutions, what are the variables which make the optimal solution? Okay, so this became my new tableau. And in my new tableau, the bottom row became all non-negative. So step 9 says, once the left side of the left row, left side is here, is all non-negative, the solution can be found. Okay. The value of each row variables or active variables is equal to the rightmost entry in the row. All inactive variables equal to 0. Okay. Now, I have checked the optimality condition and understood that my optimality condition is satisfied. Now, the rule also says now how I can find the variables now which optimizes this. It is now mentioning about the active variables and inactive variables. So let's clarify this. Let's see what these means. So optimality condition is satisfied, and what is the solution? In finding the solution, remember that in each column we try to make one entry 1 and the others 0. If I can manage to do this in some columns, now the resulting variables I call the active variable. The other variables I call the inactive variables. So x is an inactive variable, t is an inactive variable. Okay, and the active variables are s, y, and p. Inactive variables are x and t. So the optimum solution, I take only the active variables values which is y is equal to 2. Y is equal to 2 because I look at the row where y is equal to 1 and this row value gives me 2. So I take this as y is equal to 2. S, look at the row where s is equal to 1. Look at the very constant value 3. P was my performance, of course, that I wanted to maximize. Okay, 1, look at it, 10 in the row. So I put it here, 10. Wherever I cannot manage to do this are called the inactive variables. X is equal to 0, t is equal to 0. The inactive variables I make 0. But now in the optimum solution, I do not consider the slack variables. Although I found a variable for s is not a real variable, it's a slack variable, so I ignore it. So I just look at x and y variables. X was an inactive variable, so it is 0. Y is an active variable, I found it 2. And my optimum solution is then found at 0, 2, which is 10. Now, I wrote this as a rule here. How to find the optimal values? These can be found by distinguishing the active and inactive variables. An active variable can be classified to have a single one value in its column and the rest be all zeros. So, this is an active variable, active variable, active variable. If a variable does not meet this criteria like x and t, it is considered inactive. So they are inactive. If a variable is inactive, it means the optimal solution of that variable is 0. So I put them 0 here. If a variable is active, the row that contains the one value, it corresponds to the optimal value. So for the y, it is 2. For the s, it is 3. And at the optimal solution, only the real variables, not the slack variables, are considered. So this becomes my optimal solution. I assume that it is all new stuff for you. I assume you haven't met this before. So whenever you meet a all new subject, it requires some time to digest. But I hope when you go through this, through the slides, it is all going to be more clear for you all. And the table of 9 steps that we put at the beginning of the simplex method makes more sense.